guys, welcome back to Equiscience Hubs. I know it's been quite a while, but as you can see, it's been on holidays again, and actually the video is not up because it's currently been blocked by YouTube for copyright issue. But anyway, so today I'm kind of like launching a new concept on the channel where we're gonna be, instead of covering a topic sort of like fully from a fairly wide angle, I thought it would be interesting to look at a particular scientific paper. So we are going to be taking one piece of scientific research and sort of like go through it and analyze it, see how the experiment was conducted, what were the results, what are the pros and cons of it, and you know what could be improved and what are the main conclusion of it, obviously. But to start with, I thought it would be quite interesting to go through with you exactly what is a scientific paper and where can you find them, how publication process works, how is it built, etc. So this is the idea of that particular video, is to start, well, debunking science, and let's get going. So where can you find papers? Well, I personally use two sites mainly. The first one is Science Direct, where if I start on a subject, I usually go onto Science Direct and look at it and, you know, do a search through it. If I'm looking for a particular reference, then I'll usually use Google Scholars. You normally have to pay, unless you're part of a uni or a research group, you have to pay rights to access papers. Also, you know, there are ways around it. The publication process, how does it work? Well, let's say you're a team of scientists and you've made a very fascinating discovery and you want the rest of the scientific community to know about it. Then you will write an article, or you know what we call a paper, and you will send it to a journal. And that journal will then get normally 2 reviewers to go through your paper, and they will then say whether your paper is good enough to be accepted, whether it needs correction, or whether it should be rejected by the journal. The peer reviewers, it's a process of peer reviewing, as we call it, and it should be anonymous, and the people reviewing your paper should be, in theory, experts in the field as well. The author journals are not equal in terms of, like, it is more prestigious to publish for some journals than others. One way of checking that out is to check a journal impact factor. So the impact factor is the calculated number of times selected articles are quoted within the last few years. And, you know, the higher the impact factor, usually the more selective the journal is, the more difficult it is to get published in that particular journal. Also, you know, it's not an absolute rule because, you know, let's say you have a fairly new journal that's suddenly been, you know, publishing for a few years. Of course, your impact factor is going to be much lower because you haven't got the same amount of papers published. The other thing as well is that you can have, you know, a niche effect. So, for example, in equine sciences, it's a very, you know, restricted subject really. And, you know, if you look at, for example, the Equine Veterinary Journal, which is one of the biggest journals in equine sciences, the impact factor is only 0.941. So please bear that in mind. When it comes to the structure of a paper, there is an international consensus about it. So whether you're publishing in maths, in physics, in psychology, in biological sciences, you know, the structure of a research paper will always be the same. So first off, you'll have the title, which is usually a lot more complicated than what you then find as being vulgarized in magazines. you have the author's name. I personally quite like, if I'm researching something, I quite like to check the work of the different authors and see what else they've published on the subject. It kind of gives you an idea as to how much expert they are on it. The journal is the next one, and you've already mentioned that. The first real section will be the abstract or the summary. So in that paragraph, it's usually, well, it is a paragraph long, you will find pretty much all the main information that will then be covered in the rest of the paper. The introduction is the first real part. As it says, it's an introduction, so it will cover the subject from a fairly wide angle, usually give a background to the study, establish which other work's been published on that beforehand, and why is that particular piece of research relevant, why is it important to do it. Material and methods in the next section, so there you'll find it's basically the protocol of the experiment. So strictly speaking, you should be able to read the material and methods, and then you'll be able to reproduce exactly the experiment like the researchers have done it. Of course, providing you've got the right equipment and stuff like that. You'll have everything from, the numbers used, the equipments used, the exact protocol, the statistical analysis, which we'll get back on a little bit later on. The next section will be the results, and this is just purely and simply the raw results. There's nothing else about it. You just have the numbers or the main findings. That's usually where you'll find all the tables and the nice little graphs as well. The last section will be the discussion, and this is where you'll get the interpretation of the results and potentially the hypothesis as to why the researcher got that, the ideas, or simply no real explanation at all sometimes. I personally quite like, if it's a subject I'm quite comfortable with, I quite like to read a paper, stop at the end of the results, and just take a few minutes to reflect on what the results were and try to formulate my own hypothesis before reading the discussion. It's always quite interesting. In the discussion, you will potentially also find things like the limits of the study, or what else needs to be done on the subject, and it gives you an idea of future openings of research on that particular topic. At the end of it all, you'll find the references. So all the papers that have been quoted in that particular piece of research or the entire list will be put at the end. It usually follows what we call the Harvard system, where you'll have basically the author's name first, so name, first name, just the first letter usually, so year, the name of the study, the journal where it was published, the issue of the journal, and the page numbers. I would like to make a little point about stats. So the statistical analysis. So the stats will allow you first off to see whether the numbers you've used in the study, if your sample size is big enough for it to be relevant, whether you can actually run further tests onto this data. So if you have an effect, we will say in sciences that the effect was significant. In order to do that, so you run tests on it, which will differ depending on the type of data you've got, and it will give you a p-value. Your p-value for most this is a hard one. For most statistical tests, your p-value has to be under under 0.05 to be significant. It is better if your p-value is under 0.01. So, for example, I was reading a study recently about the effect of alpha-casozepine onto loading horses. And the study showed that there was, using the molecule, there was a significant reduced amount of time in order to load a horse. And that effect was significant at p equals 0.04. And you think, great, you know, there's actually a molecule that can help me to load my difficult horse. But if you actually look at the results themselves, then, you know, it was significant, but there was only a reduction of 0.45 seconds between the treatment group and the control group. So, you know, is it really relevant? So you may also want, with your data, to check whether there is a link between two sets of data. But it's important to remember that correlation does not necessarily mean that there is causation. So, for example, we all kind of know nowadays that, well, I hope so, smoking increases your risk of lung cancer. So there is a correlation between the two, but there is also causality between the two. But probably the most infamous example is the link that was made back at the beginning of at the end of the 90s, 1998, there was a study that found that there was a correlation between the measles vaccine and autism. I mean, that study has since then been, you know, refuted by the rest of the scientific community, and there was actually two studies about it. One in 1998, one in 2002. And you read the study and initially you think, oh, there's a link between the two, and so you have all that anti-vaccine movement that got, you know, created, etc. But I'll put you a link in the description that, you know, goes through the studies and actually explain to you why they were flawed. And it's important to bear it in mind when, you know, reading stats or reading a study. Right guys, so this is it for today's video. It's just a really brief overview of what is a scientific paper and, you know, a little bit to bear in mind when thinking about statistics. So I hope you enjoyed it, and I mean there would be a lot more to say about it. I think, you know, I would probably make another 30 minutes long video, so, you know, so I'd avoid that for now. And I shall see you in the next video where we will be covering a scientific paper.